Lesson 4.2, Constant Rates of Change. A rate of change describes how one quantity changes in relation to another. So let's look at this table here. We are comparing time in seconds to distance in inches, IN. And so after 1 second, we've gone 3.5 inches. After 2 seconds, we've gone 7 inches. And after 3 seconds, we've gone 10.5 inches. And so we could say our rate of change is 3.5 inches, or IN, per second. And the reason we can say that is because every second we go 3.5 more inches. A relationship is proportional when there is a constant rate of change. When there is a constant rate of change, the relationship is proportional. Now, to check and see is this relationship proportional, we can compare the ratios in the table. Now, let's call time in seconds, let's call that the x value, and let's call distance, the inches, the y value. And that's normally how you do it. You call the top row in the table x and the bottom row y. So let's find the ratio of the y values to the x values. And if the ratio of the y values to the x values is all the same, or if the ratios are all equivalent, then that tells us there is a constant rate of change. So let's compare y to x. So here we have, this is the y value, 3.5 to the x value, which is 1. Well, what is 3.5 over 1, or 3.5 divided by 1? That is simply 3.5. All right, so that is our first value. Now let's compare this column. We've compared this column, now let's compare the second column. So compare the y value, 7 on top, to the x value, 2. All right, what is 7 over 2, or 7 divided by 2? That is also 3.5. And so as you can see, this ratio, 7 over 2, is the same thing as this ratio, right? They're both equal to 3.5. And so that's a good sign, but we need every value in the table to have the same rate of change for the relationship to be proportional. And so we've checked this column, we've checked this column, now let's check the last column. We have our y value of 10.5 over our x value of 3. What is 10.5 over 3, or 10.5 divided by 3? That is equal to also 3.5. And so all three of our ratios are equivalent. They're all 3.5. And so we could say 3.5, this is our constant, it's our constant rate of change. It's our constant rate of change. And like we said before, every second we travel 3.5 more inches. That's what the table is telling us. And so we use something called the constant of proportionality. The constant of proportionality, which represents the constant rate of change in the relationship between x and y. And the variable that we use to represent the constant of proportionality is k, a lowercase k, which stands for the constant of proportionality. When there is a proportional relationship, we can use this equation. We can use y equals kx. Y equals kx. We can use that equation to describe a proportional relationship, where k represents the constant of proportionality. And so from this table, if we wanted to write an equation to describe this proportional relationship, we found the constant rate of change, or the k, right? The k, which we found by taking the y values and dividing by the x values. The k was 3.5, right? That was our constant rate of change. And so what we can do is use this equation, y equals kx, and plug k in, which we found was 3.5, plug k in for x. And so the equation would be y equals k, which is 3.5x. Y equals 3.5x. This would be the equation to represent the proportional relationship in this table. Let's do two examples. All right, example number 1, we're comparing time worked in H, or hours, to our total wages in dollars. So what we need to do is in this table, let's call one value the x value and call the other value the y value. We normally call the top value x and the bottom value y. Okay, and to find k, which is the constant of proportionality, to find k is equal to the ratio of the y values to the x values. You take your y values and divide by your x values. So let's do that and let's see if our rate of change is constant. So let's take 8 over 1, right? 8 over 1. What is 8 divided by 1? That is 8. Okay? Now let's check. We've checked this column. Now let's check this column. Take the y value 16 over the x value. 16 over 2. 16 over 2. What is 16 over 2 or 16 divided by 2? That is equal to 8. Okay, we've checked the first column, checked the second column. Now let's check the third column. Let's check the y value 24 over the x value 3. So 24 over 3. What is 24 over 3 or 24 divided by 3? That is also 8. So as you can see, the constant rate of change, the k, is 8. Right? All of these, this is the k. It tells us what the k is. So to write an equation, we would say, first off, we would say, yes, this relationship is proportional. And why is it proportional? It is proportional because it has a k. It has a constant rate of change. And so using the equation y equals kx, we can now write an equation to represent the values in the table. We already found that k is 8, so we need to plug 8 in for k. And if we do that, our equation would be y equals k, which in this case is 8x. So y equals 8x. And so what this is telling us is basically we're making $8 per hour, right? $8 times the number of hours. That would give us our total wage. So the equation that we write is y equals 8x. One more example. In this example, we are comparing time in minutes to the number of texts. Okay, so let's call the top value x, let's call the bottom value y. Let's see if there is a k. Is there a constant rate of change? To find k, you would find the ratio of your y values to your x values. So what we're doing here is to find k, you take your y values and divide them by your x values and see if all of the ratios are equivalent to one another. So first, let's look at the first column. Take the y value 6, over the x value 2. What is 6 over 2, or 6 divided by 2? That is 3. Okay, let's check the second column. 12 over 4. The y value 12 over the x value 4. What is 12 over 4? That is also 3. We got one more column to check. We've checked this one, we've checked this one. Now let's check this one. Take the y value 21 over the x value 7. What is 21 over 7 or 21 divided by 7? That is 3. Okay, so as you can see, all of these ratios are equivalent. 6 to 2 is equivalent to 12 to 4 is equivalent to 21 to 7 because they all simplify to 3. So 3 right here is our k. It's our constant rate of change. And because there is a constant rate of change, this relationship shown in the table is proportional. And if it's proportional, we can describe that relationship as y equals kx, where k is the constant of proportionality. And we just found the k for this relationship. The k is 3, and so we plug 3 in for k. So the equation that we can write to describe this proportional relationship is y equals k, which in this case is 3, y equals 3x. This would be the equation to represent the proportional relationship in the table. Now the two examples that we've shown here both had values for k. They both had a constant rate of change. And what you will see though is not every relationship is proportional. There are some non-proportional relationships. And so if you take the ratio of the y values and divide them by the x values and you don't get the same number, you don't get a constant rate of change, then that would tell you that the relationship is not proportional.